In our last section, we talked about rational functions, and we talked about what happened when they were proper rational functions. But what happens when they're not proper? What happens if we just have rational functions? Now, remember, a proper rational function has the degree of the top is less than the degree of the bottom. So we have to make sure that we know whether it's proper or not, because there's different things that we have to look at. So we have to first look at the degrees and decide if it's proper or improper. Which is it? Is the degree of the top less than the degree of the bottom? Is it equal? Is it greater than? What can we do to decide with that? Just look at those degrees. Then the next thing we want to know is it reduced? And if it's not, reduce it. But make sure you make note of any holes. Any of those terms that cancel out. Then we have to look at our horizontal or oblique, which just means slanted, oblique asymptotes. And I'll show you how to find those. Remember, if it's proper, the horizontal asymptote is just y equals 0. Then we want to look at whatever vertical asymptotes we have, which is what's left after we've reduced it, what makes the bottom 0. Then we look at the x-intercepts and the y-intercepts. And then we graph it on our calculator and sketch it using all this information. So we're going to look at these different steps and how to deal with them in some examples here. So let's look at this function. Alright, so the first thing is to look at the degree and decide if it's proper. Okay, the top degree is 3 and the bottom degree is 2. So that means it's improper because the top degree is greater than the bottom degree. Now, we want to reduce this and see if we can find some help with that. So we factor. We have x squared plus 3x minus 10. Now this bottom factors pretty easily. So let's finish factoring the top. Now remember, you can use the factors of one that factors easily to try to help you get the factors of the other one because you want them to all work together. So it's not reduced, but we can reduce it. So this is the reduced version. So this means we have a whole at 2. And if we plug it in here, we see that the whole is at, this is going to be 2 times 7, which is 14 over 5. So the whole is going to be at 2, 14 over 5. So then we need to know if we have an asymptote. Now, the best way to find an asymptote is to take the rational function and make it proper. The way to make a function proper is with long division. Remember, this fraction, what it means is the top divided by the bottom. If you had the fraction 5/3, then this is an improper fraction. And the way you make it proper, or a mixed number, is you take the 3 and divide it into the 5. So we say 5 divided by 3, it goes in there one time with 2 left over. And that's how we get it our mixed number. Well, the same thing happens with these rational functions. It's exactly the same thing, just has functions in it instead of plain numbers. So we take our top and divide it by the bottom. So how many times does x squared go into x cubed? It goes in x times. So we multiply all those through. And then we've got to subtract everything. So that changes all those signs. So those cancel, and we're left with 2x squared minus 4x. So then how many times does x squared go into 2x squared? It goes in twice. So we have 2x squared plus 2x minus 12. And then we need to subtract all that. Those cancel. And this is what we're left with. So what does that mean? That means that this rational function, f of x, another way to write it as a mixed number type setup is x plus 2 plus negative 6x plus 12 over x squared plus x minus 6, just like we did with the numbers. We take our whole part, and then our remainder is left in the fraction. So this is the proper form of this rational function. This one's improper, this is proper, but it's still the same exact function. It's just rearranged a little bit. Now, how does that help us? Well, whatever you have here, this whole part, that is your oblique asymptote. Now, if you have a number there, that will be your horizontal asymptote. But because we have this line, y equals x plus 2, that's an oblique asymptote. Now, we also need to look at vertical asymptotes. So a vertical asymptote we're going to have is x equals negative 3, because that's what's going to make this bottom part equal to 0. So let's see here. Running out of space again, as usual. So we'll go up here. We're looking at the places, the intercepts. So if we have x equals 0, then we end up with 0 on the top. And if we have y equals 0, well, how do we get y equals 0? Well, that's when the top equals 0. And that's, let's see here. We already factored that here. So this is what that factors to. So we know that 0, negative 5, and 2 are going to make the top equal to 0. Well, we've already got the 0 here. We already know that that's going to be one of the places that it intercepts. We know that at 2 we have a hole, so that's not going to work. So negative 5 comma 0 is our other intercept. Now, the next thing you're going to do is just graph it on your calculator and look at this and make sure that you have all this information in here. You'll have to make sure you put your hole in at 2, make sure you have your vertical asymptote at x equals negative 3, you'll have an oblique asymptote in at y equals x plus 2, and you'll have your intercepts drawn in here. So graph it on your calculator and look at it. Make sure you've drawn in these things and then put a sketch. We'll do some more examples of this in class and make sure that we've got this. Just make sure you have all the steps written out and then think through them all. Or make sure you realize how to make an improper rational function rational using long division and what this shows you with the whole part and the fractional part. Make sure you've read the section and taken some good notes and written down any of your questions.